All right, welcome to week 2 human geography. The first thing we're going to do today is to take some notes. And so you should have a notebook out, and anytime you see something on my slides I'm going to go through here in a minute that is highlighted in yellow, you are going to write it down into a notebook. The good news is that you are going to be able to you use those notes then on a test eventually. And so the first unit that we're going to do is population and migration. And we're going to focus on population terms. So when we start talking about population, there are different ways to see population. And there's also a number of terms that you're going to need to know and understand why population looks the way it does. And so we're going to go over some of those terms today. All right. So the first thing I want to show you, and you can kind of look at this a little bit more closely on your slides. So this is my video, but the slides are right below. So if you want to kind of go at them on your own pace, you can do that. Is just a cartogram of world population. So a cartogram is a map that intentionally distorts the size or distance to something and shows variations of a particular geographic feature. So this cartogram is blowing up or shrinking down different countries based on the amount of people that they have. So you can see that India and China are really, really large. You can see that Nigeria here in Africa is particularly large as well. This is another way to look at a cartogram. This one kind of takes little boxes, and those boxes are each representing about 500,000 people. And so you can see that Canada up here is a relatively small population compared to the United States. If I go to the next page, you're going to see India and China very much making everything else in Asia look particularly small. Japan's pretty big. Down here, though, is little Australia. So even though Australia has a big space, they are relatively small in terms of population. We would also use a dot map. So we took a look at this last week, but you may also use a dot map to take a look at world population distribution. And that is where there is a single dot that represents something. In this case, a dot on this map is representing 100,000 people. And you'll see in the dark areas, there's just a lot of people there. So those dots don't really look like dots anymore. They just kind of look like a sea of red. But you'll also notice that the world population is not distributed very evenly. There's a lot of sparsely populated areas, like we already mentioned, like Australia, northern Russia, and eastern Russia, Canada, parts of the United States, parts of Brazil even. The Sahara Desert is very sparsely populated, not a whole lot of people living there. And we could also take a look at population density. We'd see similar patterns. We could take a look at it in an isoline map. And an isoline map would show us that different places are a lot more densely populated, which just means that people are packed in really tight. Okay, so you are in this slideshow. There are 2 videos. I'm not going to show them to you on this video right now, but you are welcome. You should be watching them on your own. So there are a couple short videos. These videos were both made when the world population reached 7 billion people. And today's world population is no longer 7 billion people. We're actually at 8 billion people. So although the videos are a little bit old, they do kind of focus on some population trends. And I think they're really interesting. Okay. So here we're going to start our note taking. I'm going to put in yellow anything that you should write in your notes. So please make sure that you do that. You may use all handwritten notes on any unit test, and make sure that you use a big unit title on a fresh page when we start a new unit. This will make finding your notes easier for the exam. So here is our unit. So in your notes right now, you should be writing Unit 1, Population Migration. I'm going to go pretty fast through these notes. I'm not going to give you a lot of time to write, but because this is a video, you can just stop the video and pause it whenever you need to. All right, here we have population density. So our first term is population density. So make sure you write that definition down into your notes. And population density is the number of people in an area divided by the total land area. So density is how packed in people are. And so we would take the number of people and we would divide that by the total land area, and we would get the density of a particular area. So we can take a look at density on a dot map. We could also take a look at different types of maps. We can see that places like India, Bangladesh over here, parts of Europe are really densely populated. Japan's very densely populated. And places that, like Canada, for example, are not very densely populated, or Australia, as we already mentioned. Okay. So the other thing that we talk about when we think about populations is populations are constantly fluctuating. They're constantly rising and falling. And really, there's only a couple factors that cause populations to rise and fall. It's a really pretty simple equation. And the way that populations rise, one of the ways that populations rise is because babies are born. And so we need to understand the birth rate of a region in order to understand how fast or slow that population is growing or shrinking. So the birth rate is a number, right? So we can calculate the birth rate of a country or a region by taking the number of babies that are born in a given year per 1,000 people in the population. And we do it an average. So we divide it by 1,000 people in the population so that we can compare those birth rates across places of all different populations. So obviously China, that has tons and tons of people, are going to have many babies being born, but you'll notice that they have a really low birth rate. So this is compared to their total population. They have a birth rate of, I think it's close to like 8 babies that are born per 1,000 people every given year. But it's not just that babies are born. That's not the only thing that's influencing population, but there's also people dying. So the death rate then is the same kind of number, but it's the number of deaths in a year per 1,000 people in the population. And you can see this map is the map of death rate. So places that have higher death rates are going to have more people die per 1,000 people in the population than you would in places that have low death rates. So death rates can be high for a number of factors. The first factor is that you could just have really poor healthcare systems. That might, or maybe a disease or a pandemic even, right, leads to higher death rates. But another reason that countries might have higher death rates, even if they have pretty good healthcare, is if they have older people in their population, if they have a large chunk of their population that is elderly, then they're going to have higher death rates, just due to the fact that older people are more likely to die than younger people. And because of that, countries of Eastern Europe, countries of have slightly elevated death rates just due to that factor. Okay, so we take those two numbers, we take birth rates, and then we minus death rates. So birth rates are adding to the population, death rates are declining from the population, and what we get then is the change in population. We can calculate that change as a percentage, and we would get that change as the natural increase rate. So the natural increase rate is the change, the percentage change in the population from one year to the next. So how fast is a country growing? So our natural increase rates range anywhere between like -1 and 3, +3. So a population change of about 3% means that next year, your population is going to be 3% bigger. And if your natural increase rate is negative, that means that your population is shrinking. So you'll see here that populations in Central Africa are rising at higher rates than populations in Eastern Europe. In Russia, in Japan, have really low natural increase rates. So we calculate this by taking the birth rate minus the death rate. All right, there's a second video here. So go to the slides. You can watch the second video that kind of introduces patterns of global population growth. Okay, another key factor that influences population, or that we can that really tells us a lot about a country's population, is their infant mortality rate. This is a really kind of morbid number, but infant mortality rate is the number of children that die before they reach the age of 1 year old. And it's per 1,000 babies that are born. So the infant mortality rate really tells us a lot about the health systems of a country. If you have a high infant mortality rate, that generally means that mothers are not receiving a lot of health care when they're pregnant, that there is malnourishment, that there is a lot of maybe underweight babies that are born, or just not a lot of care for newborns. So you'll see large differences between places in the world that have really high infant mortality rates and places that have lower infant mortality rates. Going along with birth rate, the total fertility rate is the average number of children a woman will have in her lifetime. So this number is a number. So let's say the number is 2. That means if the average number of children a woman in that country has in her lifetime is 2. So some women are having 4, some women are having 0, some women are having 1, some women are having 8. But on average, in that country, there is an average of 2 babies being born. So you'll notice that a lot of countries in the world are below 2. Okay, so these countries here, these colors, shaded colors, are below 2. And then there's some countries in the world that have much higher total fertility rates. So total fertility rate and birth rate are directly related. So countries that have higher birth rates are also going to have higher total fertility rates. Now, the interesting thing is that women are having fewer and fewer children. So when we talk about fertility rate, the fertility rate has gone down drastically worldwide. So this is global, but in 1950, on average, women worldwide were on averaging about 4.5 or maybe 4.6 or 7 children per lifetime. And today, in 2017 at least, that number, that global number, has fallen below 3. So women all over the world are having less children than they ever did before. The projection is that by 2050, we'll be below 2. And by 2021 or 2100, will be about 1.5. So on average, women worldwide. So women are having way less children than they ever did before. And that's not just in some countries, that's in all countries of the world. Life expectancy, on the other hand, is going up. So the average number of years that person is expected to live, and that also has a lot of regional variations. So in more developed, wealthier, and more better healthcare systems, life expectancy is pretty high. And then, let's see. So we have one more term, and that's going to be replacement rate. So replacement rate is the total fertility rate. So going back, total fertility rate, remember, is this one, the average number of children a woman will have in her lifetime. And our total fertility rate is, the replacement rate, is the total fertility rate needed for the population to stay the same from one generation to the next. This is the number. So 2.1 is the number. So what this means is if on average people were having about 2.1 children, population would start eventually no longer rising or falling. So today we are at about 2.5. And so our population worldwide is still rising, but it eventually will not anymore. So 2.1 is that replacement rate. And it's 2 because a woman has a child, and that child would replace her in the population. It would also replace a male counterpart. So a husband, a boyfriend, whatever, So a woman has a child, a man needs to be replaced in the population as well. And then 0.1 is because not all children are going to grow up. There's going to be some children that are going to die before they reach their reproductive years. So it has to be slightly over 2. Okay, so to end today, there's a quick other little video, so please watch that. And the numbers, so why do we care about this? The numbers look different from country to country, and that can tell us much more about how many people there are in a country. Here's some examples of numbers. And the next thing you're going to do for Tuesday and Wednesday is work on an assignment called the Population Geoinquiry. All right, please reach out to me if you have any questions.